Okay. Good afternoon, everyone. I am Yuta Nakajima from Kitami Institute of Technology. Today, I would like to present our research titled End-to-End Assessment of Product Review Helpfulness Using Subjective and Objective Information. First, let me introduce the research background. With the widespread use of the internet, the utilization of online shopping has been increasing year by year. As a result, the number of purchases grows, which naturally leads to an increase in the number of reviews posted for each product. As reviews increase, there are several good points, such as gaining perspectives from various users, increasing purchasing motivation. On the other hand, there are also bad points. It takes more time to read them all, and the number of low-value reviews increases, which negative affects many users. To address these issues, it has been suggested that we can support user decision-making by automatically extracting reviews that are considered helpful. Next, regarding what users look for in reviews. A survey the Japanese government identified several criteria that readers find helpful. There include a large amount of information and the reliability of that information, such as whether the evaluation is based on actual experience. As shown here, multiple standards exist that influence a reader's perspectives. There have been previous studies focused on identifying helpful reviews. However, some of these studies lack a clear definition of what helpful actually is. In other cases, even when criteria are established, the actually important of each criterion, the overall helpful remains unclear, leaving a certain level of ambiguity. The purpose of this study is to support both viewing and posting online reviews. We aim to achieve this by presenting the specific characteristics that define a helpful review. By clarifying these features, we can help users find information more efficiently and guide reviewers in create high quality content. Now let's move on to the methodology. Our approach consists of three main stages. First, we established a comprehensive framework by defining 6 objective criteria for what makes a review helpful. Second, we developed a novel sampling method called LDS to efficiently curate high-quality data from large datasets. Finally, we created a manually annotated dataset of 1,200 reviews to train and evaluation our models. On this slide, we present the 6 criteria identified as a key elements of review helpfulness. These objective features labeled A1 through A6 serve as the foundation for our assessment framework. We use review data from both Amazon Japan and Rakuten Ichiba. For each review, we assigned 2 types of labels: a subject binary label, either helpful or not helpful, and objective multi labels based on our proposed 6 criteria. We have 2 annotators verify if the review met our definitions using 192 Amazon reviews. The results are shown in this table, and we confirmed that each factor contributes to the helpfulness of a review. Now I will explain our proposed method, LDS sampling. This method is used to calculate an information score for each review. First, lexical density is calculated by dividing the number of unique words by the total word count. This allows us to measure the vocabulary richness within a text. However, lexical density alone tends to overvalue short sentence because it does not consider text length. To address this, we introduce a short sentence coefficient. This lowers the evaluation of short sentence without changing the overall value trend, ensuring a more balanced and reliable assessment. As shown in this formula, LDS calculated as a product of lexical density and the short sentence coefficient. This integrated score represents the overall informativeness of a review. By applying the formula to 20,000 reviews, we can filter out low-quality short text and focus on information-rich content for our dataset. And next, I will explain the annotation process. We used the top 100 to 1,200 reviews ranked by LDS score. 24 annotators from a crowdsourcing platform assigned subject binary labels and objective multi-label based on our 6 criteria. To ensure high quality, each review was annotated by 2 people, and any disagreements were resolved by a super annotator. The table at bottom shows the final composition of our annotated dataset, including both Rakuten and Amazon reviews. Now I will discuss our classification experiments. We used 4 Japanese transformers model publicly available on Hanging Face. In these experiments, we contacted review classification, use both subjective and objective information to evaluation helpfulness from multiple perspectives. First, I will explain the setup for our binary classification experience. We use learning rates of 1e-4, 1e-5, and 2e-5 with the number of epochs set to 8. Other hyperparameters followed the trainer default values. Regarding the datasets, we used 1000 reviews from Rakuten for training and Amazon review 192 reviews from Amazon for testing. Evaluation was based on 5-run average of accuracy, precision, recall, and F1 score. The model's results used include Japanese versions of Roberta base, BART base, and Electra small. The results explain experiment 1. At a running rate of y-4, most models suffered from classification collapse and failed to run effectively. However, at 2e-5 and y-5, the performance is deteriorates significantly. In particular, the Roberta model achieved the highest F1 score of 0.838. These results demonstrate that with the appropriate learning rate, our model can effectively identify helpful reviews even in a cross-domain setting. Now let's move on to experiment 2. In this stage, we conducted multi-level classification to identify which of the 6 objective features are present in a review. Unlike the previous binary task, each review can be assigned multiple level from A1 to A6. Our goal here is to determine if their specific characteristic can be automatically detected by our models. The experimental setup for experiment 2 is similar to the first one. We used the same learning rates and models. However, the number of epochs was set to 5. For this task, we used 1000 reviews from Rakuten training and 200 reviews from the same Rakuten. They set for testing to platform and in-domain evaluation. Performance was evaluated using precision, recall, and F1 score for each level. the experiment's results. This slide shows the performance of top two models with the highest evaluation scores. Overall, levels 1, 2, 3, and 6 achieved very high F1 scores, around 0.9, while level 4 was slightly lower. Notably, level 5 resulted in 0% for all models. We believe this is because the current data structure combines the title and body, making it different for the models to distinguish title-specific features. In this experiment, we combined our findings by applying the best model from both binary and multi-level classification. We analyzed Rakuten reviews from January 2017 as a case study. For both models, we set the level short thread to 0.5 to determine the final predictions. The slide shows the classification results for each level. While levels 1, 2, 3, and 6 appear in both categories, there are overwhelmingly most frequent in helpful reviews. This clearly indicates that these factors contribute significantly to review helpfulness. On the other hand, level 4 applied in only about half of the cases, and level 5 was not functional in this analysis as well. The top 3 predict feature combinations for the Rakuten dataset. The combination levels 1, 2, 3, 4, and 6 accounts for about 110,000 reviews, which is about 54% of all helpful reviews. This suggests that this specific combination significantly impacts review helpfulness. In contact, reviews with no matching items or only level 3 are strongly associated with not helpful reviews. We compare our system's results with human annotated data. For the helpful category, top 3 combinations predicted by our models matched the human results. In not helpful category, although the rankings differ slightly, we obtained results that are consistent with human judgment. These findings suggest that by combining our 2 classification models, it is possible to achieve results consistent with human intuition. To conclude, this study achieved several key results. First, we validated that our transformer-based binary classifier can achieve a high F1 score of 0.838 in cross-domain evaluates, specifically when training on Rakuten and testing on Amazon. Second, our multi-level model successfully identified key helpfulness criteria levels 1, 2, 3, and 6, with F1 score exceeding 0.9, proving these accepts are linguistically distinct. Finally, for future work, we will prioritize improving the performance of level 5 by replacing concatenated text strings with structured inputs. We aim to hope the model better distinguish between titles and body text. Additionally, we plan to scale our dataset beyond the current 100 to 1,200 reviews and conduct formal in-domain evaluations to establish a clear performance baseline. Thank you for your attention.